Okay, so this is the video walkthrough for Exam 1 for Introduction to Chemistry, Section 80649. So this is the section that meets Mondays and Wednesdays at 10 a.m. Okay, so this is Form A that I'm going over. Form B is the same questions, just in a different order, so you'll have to rearrange the questions if you have Form B, but it's the same question, so I'll make one video for both forms here for this section. Okay, so let's just go through each question. Number 1 should be E. Okay, you're given a density, you're asked for a mass, you're given a volume in cubic centimeters. So like all these dimensional analysis, we start with what we're given here, the 10 cubic centimeters. And on the right, we're asked for a mass, okay, which is going to be grams. Clearly all the answers here are in grams, so that's the unit we're going for. And so now we have to figure out how to get from cubic centimeters to grams, and as we've learned, density can be used as a unit factor. We just have to make sure we're orienting it correctly. We want to cancel out cubic centimeters, so this bottom here better be cubic centimeters. What goes in the top? Well, the other half of the density, which is grams. And since it's 22.5 grams, we write 22.5 with the grams. And that is per 1 cubic centimeter, right? That 1 is sort of implied in this 22.5 grams over centimeters cubed. Okay, so you multiply these across and you should get 225, is E. Number 2, how many sig figs? This is either one you know or you don't. Leading zeros don't count, so these don't count as sig figs. Trailing zeros do, so there's 3 sig figs here. C. Chemistry that the branch of chemistry that concerns substances that contain carbon is organic. D, that's just a either know or you don't vocabulary type 1. Go back through the slides, you'll see that those definitions. This is a temperature conversion. We're given Celsius, we want to go to Fahrenheit, so we need to use this formula. Okay, so we put in this negative 100 for our Celsius. We multiply by 180 over 100. We add 32, and you should get this negative 148. Number 5 is just the metric unit of mass in grams. Okay, so what is the term for the mass? It's grams, second is for time, centimeter is a length or a distance, and milliliter is a volume. So gram is the only one that applies here. Number 6 is a rounding in sig figs question. Dividing 11.375 by 10, you get 1.1375, and then go back and review the rules for addition, subtraction versus multiplication and division. For multiplication division, which we're doing here, division, okay, our final answer must be limited by the number of sig figs in the things that we're dividing. Okay, 10.0 has 3 sig figs, 11.375 has 5 sig figs. We go with the least number of sig figs, so that's 3, so we need to cut this off here. And we want to report 1.13, but we have to check the next digit. The next digit here is a 7, which is a number greater than 5, so we round this 3 up to a 4. And so it should be 1.14. Answer C. 7 is a very similar question, just testing you on the different rule for addition subtraction here. And for that, we look for the least number of decimal places. There's 2 decimal places here. There's 3 decimal places here. So our answer better only be out to 2 decimal places. Right? Of the possible answers, that's only one of them. Right? Only one of them goes out to 2 decimal places, so you don't even have to do the calculation. It clearly has to be B. Number 8, we're given a volume in cubic centimeters, and we're asked for that volume in cubic inches. Okay, a lot of people got confused on this one. Just remember what that cubic symbol means. Right? It really means the centimeter unit is repeated 3 times. Centimeter, centimeter, centimeter. So there's going to have to be more than one unit factor here, because there's more than one unit that we're having to, cancel out. So this unit factor we want to use here to eventually get to cubic inches. Unit factor we want to use here, we're given in the problem, 1 inch. Oh, sorry. The bottom should be 2.54 centimeters. That's the unit we want to cancel out. For 1 inch. Right, but this only cancels one of these centimeters. So we need 2 more of those set up. 2.54 centimeters on the bottom of each of these, so that all 3 of these centimeters get canceled. Okay, so you should be dividing that 8.75 by 2.54 3 different times. And then there's a bunch of 1 inches across the top, and these 3 inches that appear across the top is what gives us the inches cubed in the final answer. Okay, so keep track of your units. So this should come out to be 0.534 inches cubed. Number 9, we're given a mass in kilograms, asked for a mass in pounds. Okay, so here's what we're given, 6.42 times 10 to the 23rd kilograms. And we're asked to get this in lbs, or pounds. Okay, we're given a unit factor of pounds to grams. Okay, the first thing we need to do, though, is get rid of kilograms. Something you should remember is that 1 kilogram is 1,000 grams, and that's what gets rid of kilograms. Okay, and conveniently, that lets us operate now in grams. And we have a unit factor now that gets us from grams to pounds. So that's what we're going to use second here to cancel out that grams and leave us with pounds. $454 grams. So doing all that math, you should get C. 10 is just a vocabulary one. Right, go back in the slides. We made the distinction between a scientific theory and a natural law. The big difference is natural law has to be something that's directly measurable, right? You have to be able to measure like with a thermometer or a meter stick or something, right? Whereas the theory is about some like atomic behavior that we can't really see. And that's what makes it a theory, because it's not directly measurable. Okay, so that should be D. 11, scientific notation. This -4 suggests we need to move this 4 places to the left. And so we wind up with 0.000225. That should be A. 12, this is a metric conversion from milligrams to centigrams. Okay. You might not have memorized a direct conversion from milligrams to centigrams, so you have to go through the base unit here. Okay, so relate milligrams to grams, the base unit. There's 1,000 milligrams in 1 gram. And then take that grams and go to centigrams, where there's 100. Centigrams in 1 gram. Okay, so that's what allows me to get the unit into centigrams. And so taking 3150, multiplying across the top, dividing by the bottom, you should get B here. 13, you're given a mass, you're given 3 measurements, and asked for a density. Okay, you can even look at the units here in the problem and realize that you have to get grams divided by cubic centimeters. And so this is a length times width times height here. So you need to multiply all these 3 numbers together. 5.05 times 2.55 times 1.25, and I get something like 16.09. There's a bunch of other numbers here, 6875. Okay, so that's the volume now in cubic centimeters. right? A density is mass over that volume. So I simply have to take this 143.584 grams and divide it by 16.09 cubic centimeters, right? Because I want grams over cubic centimeters. That's the unit of density here. Okay. Sometimes we set this up a different way, but this is one way to solve this problem. In any case, you should get 8.92 grams per cubic centimeter. Okay. 3 sig figs, right? Because these things we're multiplying and dividing together, this given information, right? These all have 3 sig figs for these length, width, and height, whereas the mass has 6, so we have to limit it to 3. Number 14, round off the following measurement to 3 sig figs. Okay, all these numbers, counting from the left, are significant. So the first 2 significant, the second 2 significant, the 5 is significant, and we want to round it to 3 sig figs. We can't just drop that last 2, right? Because that changes the number from something like 2,000 to 200. So we use this placeholder 0, which is not a significant digit. Okay. Scientific notation for 15. The decimal point is implied here after the last 0. Scientific notation is the significant digits written in this format. The first sig fig, decimal point, followed by the other sig figs. So we know it's going to be 5.58. So A's ruled out, B's ruled out. 5.58 times 10 to the something. And the something here is how many decimal places this is away. 3, 6, 9, 12, 15, 18, 21. I have to move it 21 spaces to the left. Okay, so this needs to be a positive 21. 16, scientific notation. Okay, it's not in scientific notation because it's 155. It needs to be 1.55. Okay, and so there's a couple ways you can do this. I would expand this out and type in my calculator 155 times 10 to the 5th, and you'll get 155 followed by 5 zeros. And now this is an ordinary number that you can look at and decide where the decimal point needs to move. It's implied here. It needs to move 3, 6, 7 places to the left, so 1.55 times 10 to the 7. Number 17, this is a percentage one that some people had an issue with. Okay, just remember your percentage formula is always percent equals the one thing you're interested in, right? The one component over a total amount. So some grams over a total amount of grams times 100, right? So this is the general formula for percentages. And now filling in what's given, 25 is the percent given. The total mass is 5.07, right? Because I'm asked for only one of the components, nickel. Okay, so the nickel mass is what's going on the top here, grams of Ni. This 5.07 is the mass of the entire coin, so that's what goes in the bottom. Okay, and so now you have to solve for this question mark here, which is just algebra. Divide both sides by 100. We'll cancel on the left. Multiply both sides by 5.07 so that it drops out here. And so take 5.07, multiply it by 25, divide by 100, and that should give you 1.27. Number 18, this is, again, vocabulary. Okay, we made a distinction between heat and temperature. Average is the clue here that it's temperature. Right? The temperature in the room is an average of all the molecules in the room. Okay, so 18 should be B. Nanogram, lowercase n, followed by the gram abbreviation G. 20 and 21 are similar types of compound units where you have one unit over another unit. Okay, in the first one here, it's 22 kilometers liter, and we have to get to miles over gallons, miles per gallon. And we're given the unit factors. That should allow us to get that. I'd like to start with this top unit here, kilometers, and know that I'm going to have to immediately cancel it with the unit factor. I'm going to write kilometers down here. What unit factors am I given? Well, I'm given the fact that 1.61 kilometers, so I'll write the 1.61 with kilometers, is equal to 1.00 miles. So 1.00 miles goes in the top. Right? Notice the abbreviation MI for miles. Just an M would be meters. That'll get rid of my kilometers. Now I can worry about the other unit of the given information, liters. I have to cancel that out. Since it's in the bottom, it has to appear over here in the top. And the unit factor I'm given here is 3.78 liters in 1 gallon. Multiply across the top, divide by the bottom, and that's what should give you 52 miles per gallon. Okay, 21 I'm not going to solve here because we did that in the review session. Remember, I told you one of those review session questions would definitely be on the exam. Here it is. Okay. Same exact question, same exact answers. So go back and watch that video if you didn't learn how to solve this one. And then 22, 1 terameter is how many meters? And that's just, again, that table that you have to memorize from 10 to the 12 meters in 1 terameter. Okay, so that does it. Hopefully that helps. Come to office hours with further questions, and we can go from there.